Welcome to Module 4. The title is Data Models in Electronic Health Record. Standardized healthcare data modeling is one of the most favorable paths for achieving semantic interoperability, facilitating patient data integration from different healthcare systems. You can see here the whole picture about this standardized data modeling. Electronic health record standards are various, such as CEN ISO HL7. CDA is the most used and the most known standard for electronic health record. And the more recent HL7 have been developed during these years. These standards rely on a two-level modeling method which proposes separating the flexible domain model, this is the knowledge, and the stable reference model information in two abstraction levels. Database management systems are used to find the most efficient approach to store and retrieve data. They are the center of many types of information systems. With the emergence of no one-size-fits-all paradigm, various database management systems, NoSQL stores, have been developed. NoSQL stores are a diverse family of technologies clustered according to their data model into four main models or types. First is the key value stores, second, document stores, third, column family stores, and fourth, graph stores. This classification is since each data storage model offers different solutions according to various contexts. What are the functionalities of your electronic health records? Electronic health records contain various common clinical data sets to store diverse types of patient-level clinical information. This includes all patient demographic information, past diagnosis, administrative and billing insurance data, laboratory results, medication history, vital signs, immunizations, radiology reports, and allergies lists. Adopting electronic health records provides better healthcare services by offering a better quality of care for patients, reduced data maintainability, and delivery costs, which is important for the economic aspect. What are the primary clinical use? What is the primary clinical use of single patient data? Single patient queries are performed using key parameters such as electronic health record and patient identification number. For such clinical practice, healthcare providers typically perform, create, read, update, and destroy operations. Single patient level tasks typically fall under online transactional processing, data processing systems. Secondary research use of groups of patients' data are dedicated to research-oriented practices, data not only for a particular patient, but also for a group of patients who satisfy distinct searching criteria. Also to population-based queries, extract, transform, and load data in a data warehouse, and also to analytical processing systems. The clinical data warehouse holds all patients' information, such as their examination, pathologies, or data obtained by diagnostic diverse devices directly attached to patients. Typically, the clinical data warehouse is developed to standardize and integrate data in separate silos within across healthcare organizations, enabling analysis and reporting. This data could be linked together at the patient level and used in tandem to answer questions that could not be addressed within each data silo. In the clinical data warehouse environment, physicians use data analysis techniques to compile statistics and conclude patients' health status. The secondary research use of groups of patients' data are ad hoc population query and massive parallel processing. This is the visibility of this network. Standardized relational electronic health records data, object-related mapping approach, node and path approach, archetype relation mapping approach, other relational database improvements. What about the standards integration in the NoSQL database system? They are standardized XML-based electronic health records persistence, also standardized document-based electronic health records data persistence, standardized column-based electronic health record persistence, and standardized graph-based persistence. The suitability of data storage models for medical scenarios are presented on that table. And regarding the database model, they are relational-based database, document-based database, column-based database, graph-based, and native XML database. You can see the scenarios. They are presented as clinical workload scenarios, advantages with small-size data, real-time analytics, store and query standardized patient data, also research workload scenarios, low performance due to the high joint cost of large data, clinical data warehousing, recommendation data visualization. And the native XML database is not suitable for population queries, especially epidemiological one. These are the other various types of standardized electronic health record data persistence mechanism, and they are presented as data model, methodology, pros, cons, and application. You can see that standardized electronic health records relation modeling are based on this methodology that is map of standardized electronic health records, extract into a relation table schema, pros, archive, the best performance for complex and nested queries. And also the application is to store electronic health records data for primary clinical use scenarios. These are the most known and most reliable models, and I thank you for your attention.